This is a video for AQA Further Pure Mathematics. This is Matrices 1, Section 3, Properties of Matrix Multiplication. In a previous video we'd found the following result for the product of two matrices A and B. We'd also asked the question about addition, whether A plus B was going to be equal to B plus A, and found that indeed it was. So now we're going to consider the same question, but this time for multiplication. So we can see here then that we've got the two matrices written in the opposite order, B and A. The B is of order 3 by 2 and A is of order 2 by 3. So they're certainly conformable. We can form the matrix product and we can see that we will end up with a 3 by 3 matrix. So we could indicate that by just saying, well, we've got 3 columns and 3 rows to find the elements for. Just working through that a little bit of time, then taking the first row multiplied by the first column. We see there we get 2 plus negative 2, plus 2, negative 2 multiplied by negative 1, so it's 2 plus 2, which is 4. Moving along so that we look at the second column this time with the first row, that's 3 plus negative 4 is negative 1. And then finally in the top row we can look at negative 1 multiplied by 1 multiplied by 1 and negative 2 multiplied by negative 4, giving us a total of 9. Well, we could continue in the same way and you would find that the results are as follows. The second row becomes 4, 6, 2, and the final row negative 13, negative 2 and negative 24. So clearly, I mean, there are different orders, A, B, the product A, B and the product B, A. So clearly we've got a case here where multiplication is not commutative in general. Sometimes it can be. So we say that in general, matrix multiplication is not commutative. Well, there are other properties of matrix multiplication that we can consider. Firstly, the idea of associativity. Now, associativity is where we can place a bracket in different positions if we've got 3 matrices multiplied together. So if we've got A multiplied by B and C, the bracket can go in the position shown on the left hand side where we've multiplied B by C before then multiplying by A. Alternatively, we can do AB before we then multiply on the left by C. So associativity is indeed correct for matrix multiplication. And the final property I want to consider is that of distributivity. So we say that multiplication is distributive over addition if we have, again, conformable matrices, and we have the property then for multiplication of a bracket where we've got addition inside, that the multiplication by A can be done as AB and then adding AC. And of course, where we've got addition in that bracket, subtraction would also work. Now you can see that those two properties are exactly the same as for normal numerical number work that you've covered already. Well, one or two for you to consider for yourselves later to see if you can find matrices that have the following properties. So I'd like you to see if you can find matrices AB such that AB, the product, exists but BA does not exist. The example that I gave you earlier, both of the products existed although they were not equal to each other. Secondly, can you find D, E and F that are not square matrices but DEF, the product DEF, exists? And finally, can you find two matrices M and N such that they are commutative. So it's not, as in general we've decided that multiplication is not commutative, but occasionally you'll come across matrices where the products are equal to each other. That's the end of this video. In the next video we'll be looking at section 1.4 using zero and identity matrices.